So we'll jump right in. I'm kind of assuming that hopefully everybody here is more of a Python person than they are an R person, because I'm kind of going to go through some of the basics. The idea here is, at least whenever I started looking at R and everything, it's kind of a foreign language if you come from something else. Some of the things will kind of drive you nuts at first. Personally, I love the language. The more I got into it, it took a little bit of time, but even with 10 years of experience in Python, I still find that a lot of times when I'm doing exploratory data analysis, R just tends to fit my mind a little bit better and I get things done faster. So that's one of the reasons why I kind of advocate for using both. So let me just go through some of the reasons, because I'm hoping I can also kind of convince some of you. I'm assuming some of you are coming in here as skeptics, and maybe I'll go through at least a handful of the reasons why I like using it. So first off, probably first and foremost, it's data-centric. I mean, this language was literally created for doing data analysis. Python's obviously more general purpose, and it's a fantastic language for all of that. Oh.
Oh, yeah.
Should I use this instead?
No. Just talking to
Okay. So yeah, I mean, Python is a great language for general purpose computing, and it's becoming better and better and better every day with all the PyData, SciPy packages and everything. And it is a fantastic language for actually doing data analysis, but I still feel like, you have a language that is essentially a DSL, a domain-specific language for data analysis. So it just seems to fit, right? Another is it has tons of battle-tested, high-quality packages. This is a language for statisticians, so of course, anything that you would ever want to do, any sort of analysis you'd ever want to do is going to be somewhere in there. So having access to all of those is going to be a really nice tool set for you, even coming from the Python side. And we'll actually see a little bit later on how to actually pull those two things together towards the very end. So. Its data visualization capabilities, and I'm going to go with ggplot2 here, is just, I think hands down the best. It uses something called the grammar of graphics, and that really makes all the difference to me. It basically wraps up in a very nice way, kind of a language that you use to interact with your data in a visual way. It takes a little bit longer to get used to. I mean, honestly, if you come into R and you use plot, you're going to get something up and running faster. But I think a little bit of investment in ggplot2, and you'll have something that, it makes it so much easier to actually do your data visualization and just reason about what you want to visualize. So. And this is also coming from somebody who did it's like an O'Reilly course on matplotlib. So even though I'm a Python fan and I like matplotlib and it's fantastic, I still find ggplot2 a much easier, library to use for visualization. Okay, now this one's probably my most controversial statement, I guess. But personally, I feel like it just feels like it fits more naturally with data. R is a functional language. So if you're coming from, Python, this is going to seem a little foreign to you, but, the idea of actually taking a bunch of functions and kind of pipelining them together in a way that transforms your data, so you have this kind of pipeline flow of data all the way to the end, just seems much more natural to me. And the libraries, things like dplyr and magreader, are basically built up to allow you to do that. And the fact that R is also a very malleable language, it allows you to create domain-specific languages within it, just makes it so much simpler, I think, and just more intuitive in your mind once you start working with it. So these are going beyond just basically the data aspects of it, but it's an interesting language. Once I got past the blemishes that I first came across in the language, which we'll go over here, and hopefully I will get you past and you can immediately go into just enjoying the language. It's actually really interesting. If you're into languages, you've probably been into Lisp at least at one point in time, and this is a heavily Lisp-inspired language, which makes it really cool in my opinion. You'll see that the language is, like I said, it's actually a very malleable language. You have, something that's kind of equal to Lisp's macros inside of here. So, it's just a cool language to learn just from expanding your mind, it's like that perspective. And then finally, I would say it can be a good source of ideas for the Python community. So once you get in here and start playing around with some of the things that R has, one of the things I love is that it has a thing called data packages. So people will just take a bunch of data that they find interesting, they'll put it into a package, and now you just import it like any other library, and you have access to all the data. It's in a nice data frame. You have all the documentation on all the variable names and everything right there in your actual IDE. It's just so much easier to work with. I'd love to see more like that, more of that stuff come over to Python. As I mentioned, the ggplot2 library is just fantastic, so that's a good source of inspiration. And then we'll see a little bit later the IDE that they have for RStudio, which is just hands down still the best for interactive analysis. Oops. So in addition to that, just learning R is going to open up a whole new world of resources for you. Some of the best books out there on data science, my favorite is the Introduction to Statistical Learning, which I'm still kind of working my way through, is once you learn R, they'll basically be there for you to pick up. So by not knowing R, you're kind of shutting off like 50% of the world of knowledge out there as far as data science goes. And then we get to the RStudio suite of tools. So the RStudio company has done some fantastic work. I mean, they have probably hands down the best tools that you can get. The RStudio IDE, which you see down here in the bottom right corner, is probably the best thing that you can get for like interacting with your data. I know there's Spider on the Python side, and I think there's a Rodeo one that I think is now kind of defunct maybe. I haven't seen an update on it in like 11 months or so. And they were kind of trying to compete with this, but I haven't seen anything come close just yet. In addition to that, you have things like our Markdown, our notebooks, which make it easy to do reproducible research and actually package it up and send it off to whoever you need to. I think it's actually easier to do our Markdown and send an actual nice document off to this, your C-suite or whatever, as opposed to like a Jupyter notebook. And then you have things like Shiny that allow you to do these really interactive dashboards that are fantastic. And it's the least disliked language in the world right now. So according to statistician David Robinson at Stack Overflow. So there you go. There's a reason people don't hate it that much. So those are all my reasons for why you need to learn R. So hopefully everybody's now like, oh my God, I can't wait to get into this and everything. So now I'm going to get you past the barriers that I had whenever I got into R. So what you need to know as a Python developer. So first off, dots and dollar signs. This thing drove me nuts. The very first time you look at a piece of R code, what you will probably see is something dot something or whatever, and you will be thinking to yourself, oh, that's an object and a method call. That is not. R is a functional language. And in fact, the legal characters for function names include letters, numbers, underscores. These are all pretty normal. And dots. This one drives me nuts. It's about one of the, it's second to the dollar sign as the ugliest thing in the language as far as I'm concerned. So if you look at a function like data.frame, this is actually a function call, not an object and method call. So you notice that you also see a couple more in there. You see row.names, check.rows. So this has been a pretty long-standing common practice. So you're going to run into this just about everywhere you look. It's all over base R. And it's no longer really suggested that you use dots in your names, and we'll talk a little bit about that when we get into the object-oriented system. But also notice you see strings as factors down there as the bottom in camel case. So you can see that even base R can't figure out what the hell they want to do. So, it is one of the things that will drive you crazy is that no one really has come up with the way that they want to do all this stuff. So there is a Google style guide and there's a Tidyverse style guide. I would suggest looking at those. Those do suggest underscores for everything. So that's a good place to look to make sure your code doesn't drive you as nuts as some of this other code drives me. So if dots don't actually do anything, if they're just part of the name, then how do you actually access the attributes inside of an object or whatever? Well, first, remember that there's, objects act a little bit differently because it's functional language, so you're not going to be accessing methods, in some cases, but we won't get into that. But anyway, you do have the ability to index and get attribute access through these two operators. So you have a dollar sign and double brackets. So we'll create an object. So this is my first example. And in R, almost every object is going to be a list. A list is just basically a heterogeneous coupling of data. So you have all the different data types you want. There's also a vector, which is a homogeneous type, which we'll see that in a little bit. But here's my object representing the when I started LinkedIn. And we want to get access to everything. And we can use either the dollar sign or the double brackets to do so. Now notice I'm pulling in a library called glue, and that's another thing that drives me nuts. The string manipulation kind of in R is not the best, right out the door. So glue is a nice tidyverse package that provides string manipulation and interpolation. So you can see here it's starting to look a little bit more like what we would normally work with. So And I'm just basically calling me $first name to get the first name, and then the double brackets gets you the second value, last name. And notice that R is 1 indexed. So that may also drive you nuts. So this is good. We're getting all the awful stuff out of the door right now. You will come out of here and be like, okay, whew, I've seen the worst. These are all the things that made me leave and come back and leave and come back, All right, so those are some of the first pieces, but assignment operators. So this is another one that the first time you see that arrow, you're probably going to be like, what the heck is that? Well, it's assignment. So basically, the arrow is kind of a holdover from the APL language. R is heavily influenced by both Lisp and APL. Basically, the equal sign was used for testing quality, so they had to come up with something different. Didn't think of double equals, I guess, but the arrow is there. So you can pretty much use equal ever since 2001. It's been there, but I think most style guides prefer that you don't. So you should probably stick with the left arrow. Also, there's right arrow equivalents of this. So if you actually do like a nice pipeline flow of all your data being filtered, you can actually pipe it out at the very end to a variable if you want, which may make it hard to read, but it's nice to have if you're doing interactive work. But anyway, that's beside the point. So let's take a look at an example of how this works, because there is a subtle difference between the arrow and the equal sign, and that's one of the reasons why they suggest you use the arrow. And if we take a look at our function signature for the mean function, it basically takes an x variable and then a bunch of other stuff, but we're not really concerned about that. So let's take a look at using the equal sign whenever you're passing in an argument. So here, I'm going to call the mean function. I'm going to pass in basically a vector of numbers randomly selected from a uniform distribution between 0 and 1. And we're going to pass that in, and we're going to get an average of that. Now, I'm using the local thing here because I basically don't want to introduce new variables into the global environment. So that you can kind of ignore that, but just trying to keep things clean in my notebook. So anyway, we call that, and this works perfectly. If we call print on ls, which the ls function will just give you all the actual variables and everything that are in your current environment, we notice that there's nothing there, which is what you'd expect whenever you're passing in an argument, right? If you try to basically use the arrow the same way that you would use the equal sign here, that's not the case. Basically, the arrow is going to first set the y variable in the local environment, and then it's going to pass that variable into the mean function and set it equal to the very first argument. So mean still works, doesn't blow up. If this were the equal sign, it would blow up because it would basically be telling you there is no such thing as a y argument. So yeah, it's a little bit weird. It's best if you just stick with the arrow and use equals only for the arguments passing in or whatever, right? And that just makes your code a little bit easier to understand and cleaner. And there's also the deep assignment operator, so the double arrow that we saw a little bit ago. So closest thing I can think of in Python world is probably the global keyword. And essentially this just allows you to modify variables up the call stack, so in environments outside of it. So if you look at, I guess call stack is a bad word. So if you look at it, it will search the lexical stack of all your variables. So each environment up until it finally finds one that matches, and then it'll actually change that. Where you usually see this used is closures. So here I've created a function, a closure, that basically creates an iterator variable, and it's going to return a function that just increments that variable by some offset. So the double arrow gives me access to the enclosing environments variable I. So I'm going to call that, I instantly call it with the number 2, so we're going to increment by 2, and then I just loop through and show you how it works or whatever. So you're starting to get some stuff that looks a little bit JavaScript-y here, I guess. So this is one that those are kind of the more visual blemishes, I guess, or whatever. This is one that actually kind of drove me nuts whenever I first got into it, and it makes perfect sense. In R, everything is a vector. I mean, you basically have a language whose main purpose is dealing with data, right? So data is plural, typically. So everything in R is plural as well. You can see that by this example. We're going to create a new numbers variable, and we're going to set it equal to the number 42. And if I call length on that number, I get back a 1. So it's actually a vector of numbers. And if I do a type of, now see, all vectors in R are basically defined by the type of their underlying data. So double is basically underlying data here. So we get back a type of. That type of should only really work on vectors. And then this is what I really love. So we actually take the number itself, 42, and we'll actually index it. And we'll get back the number 42. So this allows us to do, yeah, this is actually just to show you that it is a vector of 1. So if you try to index 2, you get nothing. But this allows us to do some really weird stuff like this. So we have a vector of 4 numbers, and then we just basically continue to one index and do this to infinity or whatever. So, and then this is the reason, though, why things like this automatically work in R. So basically, everything is vectorized. If we take that vector that we just made and run the modulo operation on it, it just automatically runs it on everything and returns back to us a vector of all the modded numbers. So this is one of the things that makes, using R for data manipulation just 10 times easier. It's just automatically going to do what you think it should do. So, all right, so those are most of the things that I consider to be like, it's like you need to get past it to kind of enjoy the language a little bit. So now let's just kind of go into some of the things you need to understand about the language to really use it. So as I mentioned, R is functional. It has first-class functions, higher-order functions, lambdas and closures. It allows a lot of computing on the actual language itself, and it attempts to be pure. And I'm going to show you an example of that. And this is a little more involved example. And I'm using the prior library, which is another one from Hadley Wickham. You're going to hear his name over and over again if you get into R. And essentially what that allows you to do is kind of a learning package. It allows you to kind of rip into the insides of the language and just introspect a little bit more. So what I'm going to do here is I'm going to create a new list object. And I'm going to show you how the copy on modify versus modify and place works. So I create my new object X. I'm again doing this inside of local, and this is a little bit different. It's because inside of Jupyter and RStudio, they tend to add another reference to objects. So this is one way I can get away with that not happening. So I'm going to print out the number of references, and notice there's 1. And I'm going to basically print out the address. I'm going to modify that, that variable that I just created, so that object. So I'm going to change it to the name that I prefer. And then we're going to print that again. And notice the addresses are exactly the same. So whenever there's only one reference, R is going to try to be faster for you. It's going to try to do the right thing. It's going to modify in place. When I increase the reference count, so now I create another variable y, and I set that equal to x, and I can see that now I have 2 references. Now it's going to try to be a lot more pure. It's basically going to do everything copy on modify. So if I change my name to my full name, notice whenever I print it out, this time it actually made a full copy of the object and saved it back as x. So you're going to actually run into, this is one of the reasons why R tends to be a little bit slower than a lot of other languages. It's arguable that it could be faster because, Clojure with a J has actually shown you how to do that. But its current implementation, this is a large reason why it's actually slow. So when you start getting into this language and want to make it faster, if you want to still use R, you're going to have to learn how this copy on modify works and how to actually avoid that. But this is one of the reasons why I kind of look at R as great for EDA, but maybe it's time to move over to Python once you start getting into wanting something a little faster. All right, so if you're into Python, you are obviously going to be into object-oriented programming. So you're probably going to be wondering, well, how do you do that in a functional language? And well, because R is functional, it actually has several different systems for doing OOP. And you can see each of those. But first, let's look at a couple of the different styles. So there's 2 different styles that the OOP systems tend to have. So one is an encapsulated style, and that's typically what we normally see, where methods actually belong to objects. So you have classes, all that kind of stuff. And the other one is a functional style. And if you've actually gotten into Lisp, you've probably seen something that looks a lot like this. I think it's called CLOS, the Common Lisp Object System. But essentially, you have methods that will belong to other functions called generics. And we'll see an example of this in a little bit. But first, let's go through just real quick, some of the actual object-oriented systems that you have. First is S3, which is a functional system. This one's important to know, and this one's the one we're going to go through at least a little bit to give you some understanding because it's used all throughout base R. And this is also the reason why you no longer use dots in your variable names, but we'll see that in a second. There's S4, which is also a functional system. It's pretty much like S3, but it's much more formal. S3 is very conventional. It's about as loosely done as you can possibly do and still have some sort of system or whatever, right? So we'll see how it works in a second. There's RC, which is an encapsulated system. So this is getting closer to what we're used to in most object-oriented languages. And the main reason for using this one typically is for getting past R's copy on modify semantics, so the thing that we just spoke about and everything. So we will see that a little later. And R6 is an encapsulated system, and it's similar to RC, but it's a lighter weight. It tends to avoid a lot of the problems that RC has by relying on the S4 system. And the main reason for really going over this is because it tends to be used in a lot of the tidyverse packages. So you will see that if you start to get into that. The only one that we're going to look at today, though, is the S3 system. So, as I mentioned, it's very informal. It relies pretty much 100% on convention. So it has methods that are functions that basically implement the class-specific behavior, and then you have generic functions, which are essentially your dispatch methods. They will look up these methods and run them for you based on an object's class attribute. So this is why I said it's very convention-oriented. It's literally based on a string on your object. So let's see an example. In R, you have a class or a type called a factor. It's similar to a category if you're in the Python world or whatever. So essentially, it's just categorical data. So I'm going to create a brand new vector of integers, and they have to be integers because factors have to be integers. So that's why you see the 1L here. So here's my new vector. So if I print that out, it just looks like a normal vector. Now, if I go through and I modify it, first thing I'm going to do is I'm going to add a levels attribute. So that will define basically the different categorical values that you can get. So in our case, it'll be small, medium, large, and extra large. And then I'm going to add a class. So I just literally add a string factor. And then I print. And notice the print's different. It's like now all of a sudden I've changed the type of this thing just by adding that. And the reason for that is if you look at this print.factor function, so this is actually the function that's being called. This is the method that we talked about. This is the class-specific behavior that is behind factor. The print function that I called up there is actually the generic function. What it does is it dispatches on the class factor, and it finds something that looks exactly like this. It literally looks for generic.class. So this is why you don't want to put dots in your names. There's a very good chance if you put them in there, you may actually plug yourself into the object-oriented system that comes in R. So this is also probably one of the bigger blemishes and one that can get you in quite a lot of trouble. So underscores always. So how do you override behavior in S3? Since this is a convention-oriented system, it's super easy to actually override behavior. We're going to basically subvert the current print factor function with our own. So we're going to grab a hold of the print.factor function we just looked at, and we're going to change it. We're just going to add another print that prints a string. And again, it's kind of where we're calling the generic inside of our our method or whatever, right? So this is the generic's going to look at what it gets as a string, and it's going to call the print.string function for you. So it starts to get a little rabbit holey. So anyway, we will call the old print factor function that we captured and just pass in all of the data. The ... is kind of the equivalent to *args, *quargs, or whatever. So we'll call print on our sizes function, or our data type that we had earlier, and notice it'll call our new print.factor function. So we just plugged ourselves in or override the existing behavior in the system. And then we'll just look real quick at creating a class. So here's my me object that I created earlier. Again, I'm going to just add my class attribute to it. So I'm going to call it an employee class. And then I'm going to create my new function, print.employee, and it's just basically going to pull in the statement from earlier to print myself out. And then when I call the generic function on me, the system goes through, finds the generic.class, so print.employee, and calls that function for me. So there you go. R's object-oriented system, in a nutshell. Oh man, 5 minutes, and I still have like non-standard evaluation and one more thing I gotta go through. So this is one of the more fun parts of R, whatever, is non-standard evaluation. R actually gives you direct access to the code itself that actually calculates the values that are being passed into a function. So here we have the mean function again, and first off, everything in R is lazy, so that's one of the reasons why this can happen. When I call the mean function, I pass in just a vector of values, and then notice I'm passing in this variable that just does not exist at all, and I'm passing it in with an x plus y. X plus y does not exist either, but this never computes. It never runs because I never use that data. In Python, this would blow up. It would say x doesn't exist, y doesn't exist, whatever. But here, it runs perfectly fine. So this allows you to do some weird stuff like capture the arguments. So here's a print expression function that I've created where it'll take an expression, take a bunch of different variables. It's going to capture that expression. That's what the substitute call does. The list just basically turns your list of optional variables into a list object. And then eval is going to evaluate the expression that we captured in the context of the list object that I just created. So whenever we call print expression x plus y, I pass in x and y values, and now those things are going to basically show up whenever I call evaluate because it's, I'm changing the context of where this thing is being evaluated. And I can actually print out the function itself, the code that I had too, by calling dparse, which basically takes the abstract syntax tree that I grabbed earlier with substitute and turns it back into the code. So that's cool stuff. And this is why things like this works really well. So whenever you call ggplot, the ggplot2 library, here you're actually calling it, and notice I'm passing in x and y values. First off, I don't have quotes around HP and MPG, and it's not blowing up. Those aren't variables. Those are actual names of things that I want. Second, it's actually grabbing those and using those as the x and y value axes labels. So it's actually thinking a lot of the stuff ahead of for you and doing it for you. All right, so trying to run through, because I wanted to get to one more piece, hopefully, which is at least lets you look at this one notebook. So this is RPy2. This is where it really kind of plugs everything back in, right? So now you do all of your analysis in Jupyter with Python. Python's great for general purpose programming, so you can do all of your data manipulation and everything up front to clean your data. And then if you happen to have like a function in R that doesn't exist in Python, you can just run it through. So RPy2 actually has some R magic. And if you notice, I'm basically pulling in a data set from scikit-learn. It's the Boston housing prices or whatever. I turn that into a data frame, and then I have this R magic here on cell 4, where -i says, what input do you have? I give it the data frame. And then I basically call my ggplot functions on here, and I get a nice, it's like it'll basically turn that data frame in Python into a data frame in R for me automatically, and I can do whatever I want with it. And then next is even better. I can actually use the linear regression function inside of R and perform a linear regression on it. And notice the -o here at the top. So now I'm passing that model back out to Python, and it just automatically translates it back into a model object over here, which you can actually see the linear regression that I just ran or whatever. So, all right, so I think that's probably all my time, right? So anyway, that's everything that I have. So questions, anything? Hopefully
Thanks,
I convinced
Chris.
you all to use R.
Does anybody have any questions?
Yep.
Just the last
wait.
Were you doing anything special to use it?
For this last bit here, I might have not been paying attention at the top. Did you have to sort of call anything specific to use this, or is this built into Jupyter?
So you basically, once you install the RPy2 package in Pandas, you'll get this load external or whatever. So once you call that, you have everything you need. And then it's just a matter of calling the R magics, although I think they don't call it R magics anymore on the documentation. So yeah, that's it. Super simple.
So Shiny's great for putting up running a function, putting up a ggplot. Are there any CRAN packages that'll do things like run some R code as a web service?
Well, I mean, you could argue that if you use the RStudio like professional server in Shiny, that you might have something like that. But yeah, I mean, that's where I'm kind of, I mean, that's my feeling is like, I use R for a lot of the data analysis and everything, and that's when I start to switch over to Python. Python's just great at that level or whatever, so.
Right.
Oh yeah, so down here.
So I wanted to ask about the substitute function. I noticed that you used it in one of your functions there, and it kind of confuses me. I don't understand why you can't can you just grab parameters from the function? Or do you have to use substitute?
Yeah, well, yeah, I mean, there's a couple different functions. There's quote is another one, which is kind of similar, but it just grabs exactly the expression you pass in. But substitute's kind of necessary. So essentially, you have this object called a promise, or whatever in R, or whatever is basically what each of these values are. And the moment you try to touch that promise, it's automatically going to evaluate. Substitute is just the one way that you can prevent that from happening. If you call substitute on the promise object, then it instantly turns it into an abstract syntax tree, and then you can do whatever you want with it after that. But before that, anytime you touch it, it's just automatically going to eval. So does that make sense?
Yeah.
Promises are a little deep magic. I tried to find some way that I could actually show you a promise, but everything that I read was like, okay, you just don't have access to it at the console level or anything like that. It's kind of like more under the hood, and once you touch it, it's gone. So.
And Chris has graciously offered to take questions outside in the hallway too afterwards. So if you have any specific ones, you can ask him. Any other questions here? Last one.
And I'm going to have all of this stuff up on my GitHub account and everything, so
Awesome.
you can grab everything. And I did have something on virtual environments that I was going to show, but I'm going to turn that into a couple of blog posts before the end of the week. So,
Awesome.
so there's that too.
One more question.
What is a good starting
sorry.
point?
C Roach. I should probably check and just make sure that is my GitHub account. Yep, that's it. That's usually what I go with whenever I can find it, but sometimes somebody steals Roach. Oh, and,
Sorry, last question.
yeah.
What is the good starting point for Python users to start using, learning R? How did you start?
How did I start? So I basically had an assignment at work where I needed to come up with like a KPI or whatever for. So we do hiring and everything. So I needed to come up with some sort of measurement for interviewer fairness. So basically, how much each person is sharing the load of doing interviews. And I started playing around with Python because that's what I knew best and everything. But the main thing that I had was I needed to turn in something to, a manager like 3 levels above me or whatever, right? So I needed like a PDF. And R Markdown is just, hands down the best or whatever. It's just so easy to turn into that. So I started playing around with R Markdown and R Studio and then R Notebooks as well. Our notebooks are also fantastic for like sharing and everything. So I could basically give somebody an HTML document, and it actually has the code embedded in it. You have a button that you click and it downloads, and those are basically my entrance into it, and started playing around with it from there. And then Advanced R from Hadley Wickham. It's the best book. So hopefully that helps.
Thank you so much, Chris. And
Yep.
thanks everybody for coming.